Hi, welcome back again. Steve Stumbras with Purple Cow Organics. Today, we're going to have our first segment on carbon. First of many. There's a number of topics that we'll have segments on. It's a deeper conversation. There are a lot of opinions: carbon credits, carbon sequestration, carbon markets. It's kind of a complicated topic. I don't feel knowledgeable talking about things like global warming or climate change. I think that I have enough knowledge to talk about parts per million and organic matter in the soil. So we're going to stick to that. Um, Speaking of knowledge, I mean, this guy had it figured out 400 years ago, right? He took a plant, small tree actually, put it in 200 pounds of soil. As the tree grew to 160 pounds, he was curious where that tree actually came from. The conventional wisdom in his day was that that tree was growing from the soil. So when he weighed the tree and he only lost 2 ounces of soil, he was a little surprised. Of course, today we know that the carbon in the plants that are grown here, the carbon in the trees comes from the atmosphere. We know that hundreds of billions of tons of carbon move from the atmosphere into the trees and shrubs and plants that we grow, every year. We know also that it's critically important for biology to break down that residue, organic material, green manure to organic matter to organic carbon. Soil carbon is different than organic matter, and we'll get deeper into that in some of the segments to come. We'll talk about how foliar applications can really drive the development of soil carbon if done correctly. We have a nice kind of a roadmap for growing organic matter and soil functionality as you go through a well-documented organic transition. And then, of course, the pillars of regenerative farming, that include crop rotation, cover crops, and either cows or compost, and how the growers can use that to improve their growing systems. But simply today, what I would like to leave you with is kind of this out of this world perspective on how the relationships between the ebbs and flow of carbon in the atmosphere are patterned similarly with or related to the planting seasonality here, especially in the northern hemisphere. So take a look. It's kind of a cool little few minutes long graphic from NASA. I hope you'll enjoy it, and I hope you'll tune back again as we try to dig deeper into the subject of carbon. Thanks.
Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the Northern Hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the Northern Hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the Southern Hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS 5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.